Electronegativity is a measurement of how well an atom can hold onto the electrons that it currently has, or how well it can pull electrons towards itself. So what does this mean in terms of the periodic table? Well, let's start with the periods. As we move from left to right, what happens in terms of electronegativity? Well, let's start on the left. In fact, let's start all the way on the left with group 1, the alkali metals. When you think about those elements, they all have one valence electron. So what are they trying to do with that valence electron to get happy? Well, they're trying to lose that valence electron. So how strongly are they holding on to it? If they're trying to lose it to begin with, they're not holding on very strong at all. So that means their electronegativity is very, very low. What about on the right-hand side of the periodic table? Like group 17, because remember, we always want to leave group 18 out of the trends. Group 17, something like, well, it doesn't even matter, right? They all have 7 valence electrons. So what are they all trying to do? Well, they're trying to gain an electron to be happy. So how strongly are they holding on to the ones they currently have? Really strong. So strong that they're even able to pull new electrons towards themselves. So their electronegativity value is high. So that means as I move from left to right across the periodic table, electronegativity increases. Awesome. What about a group? Well, we said as we move down a group, you get more and more principal energy levels. What does that mean? That means that the valence electron is getting further and further away from the nucleus that holds it in. Just like we said with magnets, when you're at the top of the group, the valence electron and the nucleus are very, very close to each other. It's able to hold it in. But as I move down the group and I gain more and more electron layers or principal energy levels, that valence electron gets further and further away from the nucleus that holds it in, which means it's held in less. So the electronegativity decreases. So what does that mean? That means that as I move down a group, electronegativity decreases. So in general, as we move to the right, it increases, and as we move down, it decreases. That means the most electronegative element will be found in the upper right-hand corner of the periodic table, excluding group 18. That's fluorine. And if you look on table S, you'll see that it has a value of 4.0. That's because electronegativity is based on what's called an arbitrary scale. It's just a made-up scale, with 4 being the highest value and 0 being the lowest. So if you remember that fluorine has the highest electronegativity value, that kind of tells you how the trend works. It's in the upper right-hand corner. So it must be as we move up and right, electronegativity increases. Now, it may be confusing electronegativity and ionization energy. They seem really similar. They're kind of looking at the same thing from opposite vantage points. What do I mean? I mean, electronegativity is how well an atom holds on to electrons. And ionization energy is how strongly something has to pull to strip away an electron. So it's kind of the same thing from different viewpoints. What do I mean? Well, let me see if I can make a little bit of a model here with the help of some of my friends.
So in this video, I'm playing tug of war with Barley. Now, Barley's trying to pull the toy towards him, so we're going to call him electronegativity. I'm trying to pull the toy away from him, so we'll call me ionization energy. And let's see what happens when we actually start to play here. So you can see Barley's pretty strong. His electronegativity value, really high. So that means I have to pull really hard to get the toy away from him. So ionization energy, really high. So in this video, same idea. Phantom is trying to hold onto the toy, so we'll call him electronegativity. And I'm trying to pull the toy away from him, so we'll call me ionization energy. The big difference here, the strength between Phantom and Barley is different. So let's see. Alright, so you can see here, playing with Phantom, he's weaker. So since he's holding onto it less, it's easier for me to pull it away. I don't have to pull with a lot of energy to get the toy away from him. So how does this deal with anything? Well, let's bring the two boys back side by side to compare. Now in both cases, the dogs were trying to hold on to their toy. So that's why we called them electronegativity, because that's how strong an atom holds onto its valence electrons. Also in both cases, we called me ionization energy, and that's because that was how much energy it took to pull the toy away from the dog. The same way ionization energy is how much energy it takes to pull an electron away from an atom. Now, in the case of barley, he was very, very strong. So his electronegativity value then would be high. And in order for me to pull the toy away, I had to pull with a lot of energy. So also, ionization energy would be high. In the case of Phantom, he didn't hang on as strong, so his electronegativity would be low. And as a result, I didn't have to pull away with much energy to get rid of the toy. So my ionization energy would also be low. So that's what I mean by ionization energy and electronegativity are kind of the same thing. It's just looking at it from different vantage points.
So again, electronegativity is how well an atom can hold onto or pull electrons towards itself. In terms of the periods, as we move from left to right, electronegativity increases. And in terms of groups, as we move from the top to the bottom, electronegativity decreases. As a result, we said that fluorine, F, has the highest electronegativity value at 4.0.